Hey, today we're going to talk about this thing called the Pythagorean Theorem. Pythagorean was named after a famous mathematician, Pythagoras, and it helps us find the sides of right triangles. It doesn't help us find the angles of the other two angles in a triangle that's a right triangle, but it does help us find the sides of any right triangle, and we're going to show you how that works. So first, a couple of vocabulary words. So in a right triangle, the sides that form the right angle, the ones that come together to make that right angle, are called legs. Those are the ones that are coming together to form the right angle. Now the side opposite of that right angle, which is always the longest side, and that's something to keep in mind as we work through problems with this Pythagorean theorem, this is called the hypotenuse. Now, this is a big vocabulary word. Sometimes it's difficult to say, hypotenuse, but basically it's an important one, especially when we're working on this Pythagorean theorem. So when you're looking at the picture here below, we see the right angle is being formed right here with the two legs, and the one that's always directly across, and this kind of looks like an arrow. See how the arrow almost kind of comes into this right angle box? It's actually pointing to the hypotenuse. So the hypotenuse is always the longest side of a right triangle, and it is always opposite of the right angle in that corner. So the hypotenuse is the longest side. We want to keep that in mind anytime we're looking at problems. It's kind of a little bit of a check. If I'm asked for the hypotenuse and somehow the hypotenuse answer is a little bit smaller than one of the legs, I can't have the right answer. So it's important to kind of keep that in mind. So the Pythagorean theorem. So here's how it reads. For any right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. That's an awful lot of stuff to take in, a lot of the squares, of the legs, of the lengths. It's a lot to take in. But basically, in algebra terms, this is what it reads like. The sum of the squares of the lengths. So the lengths are always the A and the B. And those are both now squared. The sum of those, so if I take the A leg and square it, the B leg and square it, and add them together, it always equals the C, which is the hypotenuse, squared. Now, down here, this says this twice. We don't need it twice. For some reason, when it copied it, wrote it twice. But C, always, always, always is the hypotenuse. It is never the legs. The C is always the hypotenuse. And it's really important to notice that and to really understand that. The hypotenuse is the C that goes all by itself on the opposite side of the A and the B in my equation. So what I'm going to basically do is I'm going to take the two legs, square them, add them together to equal the hypotenuse squared. So let's try a few examples. So first example, A. So the first question I want to ask myself is, what do I have? Do I have the A and the B and the C, or which ones do I have? Well, from the pictures up above, this would be a leg. This would also be a leg. So I have my A and my B. So one thing I want to keep in mind is it doesn't matter which one is the A and which one is the B. As long as they are the legs, then I can use either one for A and either one for B. So I'm just going to use the A for the 5. So if I use A as the 5, I would square it. I would use the B as the 12, and I would square it. And the one that's all by itself, which is the biggest one, is the C value. So that one is going to go by itself over here. So there's the equation that we're going to use. A squared plus B squared equals C squared. So now I've got to think order of operations. So exponents before addition. So I have to do 5 squared, which from a previous lesson we know is 25, 12 squared is 144, and I can't do anything yet with c squared because I don't know what that is. Then I can use addition to get 169 equals c squared. And then I got to think, well, I don't need c squared, I need c. So how do I undo square? Well, from a previous lesson, we talked about undoing is the square root. Squares and square roots undo each other. They're the inverse operation. So if I take the square root of c squared, I get c. And I take the square root of 169. Now remember, there's two answers. There's 13 and there's negative 13. But can I have a negative 13 side length? No. So my answer has to be the positive 13 only. So even though, yes, I could have done negative 13, the answer here is going to be 13. So C is going to be 13 meters. We don't attach the label because we're talking about a measurement, so we want to make sure that we include that as we go. Okay? So, number 2. Again, first question I want to ask myself is, what do I have for information? Well, first, I have a right triangle. So if I don't have a right triangle, I can't use this Pythagorean, but this tells me I have a right triangle. Then I look at what are the legs, what is the hypotenuse? Well, again, the arrow points across to the hypotenuse. So this is the one that's going to be by itself. I don't have that one. These two are my legs. Again, doesn't matter which one I want to make the A and which one I want to make the B. So what I'm going to do here is I'm going to kind of slide this a little bit. I'm going to slide this a little bit over here so that you can see the B work. So A squared, we're going to make that the 15. B squared, we're going to make that the 8. And again, we don't know what the hypotenuse is. So again, order of operations, 15 squared is 225. 8 squared, 64. C squared, I have to wait. When I add these two together, I get 289, which is nice that it's a perfect square. So when I take the square root to undo that square on this right-hand side, I get C equals, and what do I get? C equals 17. And again, we mentioned how it's always the longest side. So it doesn't answer your question, but it gives you a little bit of a check. Is 17 the longest side if I plugged it in here? It would be, right? So at least that kind of makes sense. Doesn't make it the right answer, but this number here has to be at least bigger than 15 and 8. So we're going to go with, we think we did the right work there. 17 would tell me 17 feet will be the missing length for the hypotenuse. So here's the next example. So on this example, we got to look at a couple of things. First, we need to know that we have a right triangle. So they don't sit the way they normally sit sometimes, but we still have a right triangle because of this thing. We know this is a right triangle. We got to be careful that we don't think the legs are the things that are just sitting on the bottom. We still want to look at the sides that create the right angle are the legs. That's your A and your B. And again, the thing across from the right angle is your hypotenuse. So when I go to fill this one in, I just have to be careful of that. So here's my work over here. This time, I don't know what the A is. Then my other leg is 2.1 squared. And my last, now the hypotenuse, I do know. And that one can go on the other side. Sometimes we get into the habit of saying, oh, just take the two sides you know and square them and add them together and take the square root. Well, here's a case where that's not going to be the way these steps work. So you plug in what you have to then figure out what you know. Okay? And then figure out what you don't know, which is ultimately what we have to do. So then I'm just going to go through my equation here. So A squared, 2.1 squared is 4.41. And on the other side, if I do 2.9 and square it, I get 8.41. And now I say, okay, I need A over here by itself. So now I got to think back to my multi-step equations. My first move is to undo the addition with subtraction. To move the 4.41 over leaves me with a squared equals 4. Then I can take the square root to undo the square. And again, I can't have the negative 2 that comes, which is a square root of 4. So we're only going to take the positive 2. So again, this time, just as a quick check, we're going to add the label here. It's 2 centimeters. This time, this number should be the smaller of the 2.9, because number 2.9 should be my highest number. And it is, which kind of hopefully makes me think that I did the right thing. All right, so on the next one. So letter B. Again, we'll get some more space over here. Change our color just to see our work a little bit different. So this time, what do we have? Well, again, we don't have one of the legs. So we've got to keep that in mind. The 9.6 is the other leg. And on the other side, we do have the hypotenuse. So it has to go by itself. Ooh, not that. I don't know why I put a 4. Okay, the hypotenuse always goes by itself, and it's important to note that. Okay, so again, I start figuring out, well, I need a by itself, so let's just start figuring out what we have. All right, so if I do 9.6 and I square that number, well, that is not right. 9.6 squared is 92.16, and 10.4 squared is 108.16. Then I can use my multi-step inverse. I subtract 92.16, and I get a squared equals 16. Take the square root of both sides, and again, we would get 4 and we would get negative 4. We only take the 4 because 4 would make sense for a positive side. You can't have a negative 4 side for a triangle. So our answer would be 4 meters. So on this next one, we have a three-dimensional shape. So in a three-dimensional shape, you'll see here that we do have a right triangle kind of formed from the inside. So from the middle of the base out and up for the inside from the bottom to that tip of the pyramid, we do get a right triangle kind of being cut out of the three-dimensional shape. And this thing right here is called the slant height of a pyramid. It's kind of like this outside triangle. If you kind of put this line through from the peak down to it, that's the slant height, which also forms a right angle out this way. So what we want to do is find the slant height of the pyramid. And by looking at this, we can use the Pythagorean Theorem. So we first have to note that we see a right triangle. That's first. Now, which are my legs? Well, again, the ones that are forming this right angle on the inside are my legs. So the 6.4 is one of those sides, and the 4.8. What we don't know is this line right here, which is our hypotenuse, which in this case is also this slant height. So to fill in the work here, we want to just say we have a squared plus b squared equals c squared. So a squared plus b squared equals c squared. So this time we have the two legs. This time we can just say take the two sides and square them. So we get 40.96, and we get 4.8 squared, which is 23.04, and that's still going to give me c squared. Then I would add those two things together, which is going to give me 64 equals c squared. And then to undo the square, I take the square root. Another nice perfect square over here. 64 is 8 or negative 8. We would only take the 8 because, again, we're dealing with a side dimension, which is always going to be positive. Now, some of these questions, we're seeing all these answers coming out as nice perfect squares, and we take the square root. They're not always clearly going to be that. Anything that is not a perfect square, certainly just use a calculator. Usually you can just round to the nearest tenths, or if the question more specifically says something else, then you can do that. But so far, these are all coming out to be nice perfect squares. So the next thing that we can do with this Pythagorean theorem is we can help find the distance between two different points on a coordinate plane. So here I'm going to first draw my coordinate plane. And say -2, 1, 2, 3, 4, there's -2, 5. And if I go 1, 2, 3, 4, 1, 2, 3, there is 4, -3. So if somebody said to me, what's the distance between those 2 points? You really can't just count boxes because they don't go straight up and down or they don't go straight left and right. So there is a fancy formula you can do, which you'll work a little bit more on next year. But there is this other way we can do. If you look at this, we can kind of create a right triangle. If you think about it, I could come straight down to there to meet the next height of the other one, and then I can go straight across to create our own right triangle. So once I have a right triangle, then I can very clearly use my Pythagorean theorem. So again, if you think about it, this would be A, this would be B, and there's the C, which is the distance between those first 2 points that we're looking for. So looking at the A, well, can I count from here straight down? Well, I would go 1, 2, 3, 4, 5, 6, 7, 8. Can I count from here straight across? 1, 2, 3, 4, 5, 6. So yes, this I know is an 8. And this side is a 6, and I can use my Pythagorean theorem to figure out what the C is. So 8 squared plus 6 squared is going to give me this magical C squared that we're looking for, which is that distance between those 2 points. So 8 squared is 64, 36 is C squared, which gives me C squared. Add those two together, I get 100. So again, another nice perfect square. So when I take the square root, C equals 10. So the distance between those 2 points is 10 units. So it's a way to kind of use the distance formula, which you're going to learn more about next year. But just by doing a quick visualization, you draw the 2 points. If you have a diagonal where you can't count straight up and down or left and right, you just use your Pythagorean theorem to create a right triangle, and you can find it from there. Lastly, we want to look at a little bit of a real life situation. You're playing capture the flag. So you are 50 yards north and 20 yards east of your team's base. So obviously you kind of need to know a little bit about your north, south, west, and east. So that would be kind of what your look would be for that. And you want to know the other team's base is at 80 yards north and 60 yards east of your base. How far are you from your other team's base? So let's think about what this says. And on this coordinate plane, we're going to kind of draw it out. So let's just say our base is right here. Oops. Our base here's our base. So we are 50 yards north and 20 yards east. So we're going to count by tens. So 1, 2, 3, 4, 50 would be here, and then 20 over. So actually, if we go 50 north and then 20 east, we would land here. So I'm going to take this little dot out. Take that one out. So here we are sitting. Now, the other team's base is 80 yards north and 60 yards east of your base. So what that's going to mean is this. If I go back to my base, they are saying it's 80 north, 10, 20, 30, 40, 50, 60, 70, 80, and then 60, 1, 2, 3, 4, 5, 6. So it is 80 yards north and 60 of ours. So what we want to now know is how far are you from the other base? Well, we are sitting right here. How far are we from the other team's base? So we've gotten closer, but we're not there yet. So we're looking for this distance. So what we're going to do is use the idea of, I can't just count boxes, but I can definitely use the Pythagorean theorem. So remember, Pythagorean theorem, a squared plus b squared equals c squared. So what I'm going to do is create the right triangle. So if I was to come up 10, 20, 30, 10, 20, 30, 40, I've created that right triangle. We came up 30, we went east 40 to get to their base, and it's created this distance that we're looking for. So again, in the right triangles, my A is one of the sides, my B is the other side, and the hypotenuse, which this time we're calling x, is that longest side, and that's the answer we're looking for. So we square the a's, 900, 1600, x squared. If I add 900 and 1600, I get 2500, which is a big number, and you can certainly use a calculator, but I also see that it's a perfect square. If I take the square root of both sides, I get 50 and negative 50. Again, though, we're talking in real life, so we're not talking about any negative answers here. So to answer the question, we are 50 yards from the other team's base. And that's how the Pythagorean theorem is going to work. This is definitely something you're going to see an awful lot in problem solving. But basically, whenever you see a right triangle and you're trying to find side lengths or distances between those points, the Pythagorean theorem is probably something you're going to use. It helps you a lot in real life applications, looking at different things that you might be measuring where you see triangles that are right triangles. It doesn't help you find the two missing angles that might be there in a right triangle, but it absolutely helps you find the sides. So give it a shot. If you have any kind of questions, please feel free to let me know. And that's the Pythagorean theorem.